Okay, my friends, I want to talk about pyramid volumes again, and let me give you the proof of the pyramids formula. Okay, pyramids volume formula, maybe. Okay, it can be said. And let's start with the example, and it will be, let me say it again, it will be the proof of the volume of the pyramid. Okay, formula. And listen me carefully, and please, you will understand this formula, okay, by this proof exactly. Okay, and let me, maybe the question, yes, find the volume of a pyramid whose base is a square with sides of length L and whose height is h. Okay, and listen me carefully. Let's start off with a sketch of the pyramid. Okay, and of course in this case we will center the pyramid on the y-axis, and to make the equations easier we are going to position the point of the pyramid at the origin. Okay, and let me sketch it. Okay, and this is our pyramid right now, and maybe let me sketch it again. I'm sorry, it was partially has some mistakes. Okay, and I want to show you exactly pyramid. Okay, and this part is h of height of the pyramid, and here is a surface, as you see, and which is the a of y. Okay, and this part is x and this part is y-axis. Okay, and let me sketch this triangular shape of the pyramid, okay, on the right hand side of the paper, and maybe okay, and what can we say about this? and this part is this is y, okay, and this is h, okay, and the a of y, let me show you here, okay, and this part s, okay, and also this is the y, okay, and this part is x, and let me corrections here, and this will be L, okay, and because of the length, sides of length is L, okay, and what can we say about it? And let me, we can say okay, and you can see here the cross-sectional area will be a function of y, and it will also be a square with sides of length s, okay, here is, and the area of the square is easy, but we will need to get the length of the side in terms of y, okay, and to determine this, consider the figure on the right here, okay, and if we look at the pyramid directly from the front, we will see that we have two similar triangles, and we know that the ratio of any two sides of similar triangles must be equal, okay, from the geometry class, of course. And in other words, we know that the S over L equals to, okay, Y over H, right? And so that we can say the S equals to Y over H times L, or another saying, okay, L over H times Y, okay, and so the cross-sectional area is then A of y equals to s square, right? So that means length square over height square times y square, right? And after that, the limit for the integral will be 0 is less than or equal to y is less than or equal to h, okay, and the volume will be integral from 0 to the h, okay, yes, and integral from 0 to the h, right, and the L square over h square times y square, which is the s square, of course, del y, equals to L square over h square, okay, and the integral from 0 to the h, okay, y square del y, okay, and it equals to L square over h square times, okay, and the 1 over 3 y cube, evolution bar from 0 to the h, okay, so it's equal to 1 over 3, okay, L square h, okay, which is the general formula of the square pyramid. Okay, and again, okay, my friends, do not excited about the L, which is length, and the H in the integral. Okay, once we start the problem, if we change Y, they will not change, and so they are constants as far as the integral is concerned, and can get pulled out of the integral, as you see. Okay, and also remember that when we evaluate, we'll only plug the limits into the variable, and we integrate it with respect to Y in this case, as you see. Okay, and let me give you some examples about this portion. Okay, and maybe this example will be interesting for you again. And what's that? For a sphere of radius R, and find the volume of the cap of height H. Okay, and okay, and this is height, and this is R minus H, because of the, we know that this part is R because of the sphere. Okay, and so if you choose any, okay, circle here, and this part will be A of Y. Okay, and so talk about the as you see, this will be and the A of Y is here. My friends, this is the diameter of the circles, and this part will be X, and of course this is X-axis. Okay, and this is the best illustration about this sphere of radius R and the cap of the height H, and we are after the top portion of the sphere, and the height of this portion is H, we know, and in this case we will use a cross-sectional area that starts at the bottom of the cap, which is at Y equals to R minus H. Okay, and it moves up towards the top, which is at y equals to r, because of this part is r. Okay, so each cross section will be a disk of radius x. You know that, as you see, these are the disks, okay, which has radius x. It's a little easier to see that the radius will be x if we look at it from the top, as shown the right sketching. Okay, and the area of disk, this disk is then the, we can say, the pi x square, of course. And this is a problem, however, as we need the cross-sectional area in terms of y. Okay, I'm sorry, this is y. And we need to determine what x square will be for any given y at the cross section. And to get this, let's look at the sphere from the front. Okay, and it will be, maybe, let me, okay, and okay, and this part, this is r, okay, and there is a part which is the cap, okay, and the x, we know that here is a of y, okay, and in particular, look at the triangle POR, okay, and this is POR, okay. Because the point R lies on the sphere itself, we can see that the length of the hypotenuse of this triangle, the line which is the OR, okay, is R, as you see, which is the radius of the sphere, and the line PR has a length of x, and the line OP has length y. So by the Pythagorean theorem, we know that the x squared plus y squared equals to r squared, okay, so that the x squared equals to r squared minus y squared, okay. So we know that x squared will be for any given y, and so the cross-sectional area, which is the a sub y, will be equal to, okay, pi times r squared minus y squared, as you see, and the volume will be integral from r minus h to the r, okay, and the r squared minus y squared, okay, del y, so it equals to r squared y minus 1 over 3 y cube, okay, from the r minus h to the r, okay, and it equals to, okay, and the pi times, okay, and we know that the early limits on y will be r minus h less than or equal to y, and y is less than or equal to r. So its volume will be pi times, okay, h square r minus 1 over 3, okay, h cube. So it's equal to pi times h square, okay, times r minus 1 over 3h. Okay, and the previous examples we again saw and are in the integral. However, unlike the previous examples, and it was not multiplied times the x or the y, and so could not be pulled out of the integral. In this case, it was like we were integrating 4 minus y square, and we know how integrated that. So let me continue with another example, okay, about this. And maybe lengths of curves in a planes. And also arc length and the surface area, okay? And firstly, sketch any curve, okay, which starts from A and ended to B point. Okay. Okay, and the A, B, I'm sorry, A, maybe C, B, D, okay, and the when you take any length of curves, which is this green part, okay, and this part will be del x, okay, and here will be del y, and for this part will be square root of del x square plus del y square, okay, I mean that, okay, and zoom in this part of the curve, okay, and this green line is our curves part, okay, and the other part is only illustrating, and this part is del y, and this part is del x, and this part is del L, which is the length of the curve, okay, and the del L, it equals to square root of, okay, del x square from del y square, okay, and as the, okay, delta x shows us the, I'm sorry, del x, and the delta L, which is the differentiating between the lengths, okay, and the del L, so we can say the delta y it's equal to del y, okay, and the del L it equals to del x squared plus del y squared, okay, and the total length of the curve from A point to the B point, okay, equals to integral from A to the B, okay, del L, which equals to integral from A to the B, square root of del x square plus del y square, okay, and one way L equals to, okay, on the x-axis from A to the B, okay, square root of 1 plus del y over del x square del x, if del y over del x exists in the interval a comma b closed interval, okay, and the other way L equals to integral from C to the D, okay, square root of 1 plus, okay, del x over del y square, okay, del y, if del x over del y exists in the interval C comma D. And the example, find the length of curve y equals to 4 times square root of 2 over 3 x to the power of 3 over 2 minus 1 for the interval 0 is less than or equal to x is less than or equal to 1, okay, and del y over del x, okay, it's equal to 2 times square root of 2, okay, and x to the power of 1 over 2, and we know that 1 plus, okay, del y over del x square, so 1 plus, okay, 8x, right? So the length of the curve which is given above, okay, integral from 0 to the 1, and the 1 plus, okay, 8x to the power of 1 over 2, which comes from the formula del x, it equals to 2 over 3, okay, and the 1 over 8, and the 1 plus 8x to the power of 3 over 2, and the evolution mark from 0 to the 1, so it equals to 13 over 6 units. Okay, and continue with another example. Find the length of the curve y equals to x over 2 to the power of 2 over 3 from x equals to 0 to the x equals to 2, Okay. Solution del y over del x, if it exists, okay, equals to 2 over 3 times 1 over 2, and the x over 2 to the power of minus 1 over 3, and it equals to 1 over 3 times, okay, 2 over, I'm sorry, 2 over x to the power of, okay, 1 over 3, and for this del y over del x is not defined when x approaches to 0 from right hand side, because of x equals to 0 is our boundary level, okay, and so rewrite the equation as y terms, and so 2, okay, y, okay, to the power of 3 over 2, it equals to x, okay, and now del x over del y, it equals to 2 times 3 over 2 to the power of y to the times y to the power of 1 over 2, okay, and it equals to 3 times y to the power of 1 over 2, okay, which is also 3 square root of y, okay, and if the x equals to 0 to the x equals to 2, and for this y equals to 0 to the y equals to 1, okay, when you put these values you will obtain this boundary level, and so L, which is the curve length, equals to integral from y equals to 0 to the 1, okay, square root of, okay, 1 plus, okay, and the del x over del y square del y equals to integral from 0 to the 1, okay, and the square root of 1 plus 9y del y, okay, and it equals to, and firstly let's choose by u equals to 1 plus 9y, okay, and the del u will be 9 del y, and after that, okay, when you use this substitution, okay, and you will obtain the 2 over 27 times 10 times square root of 10 minus 1, okay, so this is the total result of the length, curve length.